First of all, thank you everyone for coming to this, I think, last session of the day on the second day. I really appreciate you being here. Hopefully it'll be worth your while. Today we'll be talking about Windows PowerShell scripting with Exchange. We'll focus on some automation scenarios in Exchange. My name is Evan Dodds. I'm a program manager on the Microsoft Exchange Server team in Seattle, Redmond, in the United States. And I've been a part of that team for about 3 years now. And during that 3 years, I worked in Exchange 2007 timeframe quite a bit on the GUI and the systems management changes that we did there. And since that's released, I've been spending all my time working on PowerShell and dealing with the sort of stuff we'll talk about today. Prior to the time in the product group, I was actually about 5 years with product support services, escalation support in Charlotte, North Carolina, and I dealt with clustering and some other cool stuff. But today we're talking about PowerShell. It doesn't want to click. All right, we'll use the mouse for clicking today. Okay, so what we'll talk about today is a brief introduction to Exchange 2007 and the administrative interfaces that we have there, which primarily is PowerShell. And we'll talk about how we can do some scripting, some automation, some cool scenarios there. But the focus is that all of our administrative actions are scriptable now in Exchange 2007. So that's fundamentally new. We'll come back to how we were able to do that and why that's a benefit. We'll talk about how scripting and automation can help lower your TCO, how we can actually get more bang for the buck by using scripting. And then we'll talk about how we make it safe, easy, and fun. There's some pretty cool stuff you can do with PowerShell, and we want to show you how that's not intimidating. So we'll initially drill in, we'll talk about some of the architecture changes. If you were in the GUI session earlier this afternoon, you saw a slide of architecture. We'll actually drill in with a bit more detail in this session and talk about how that happens. We'll talk about how the GUI and command line both use PowerShell. We'll talk about how we came up with the set of commandlets that we use in 2007. There was some fundamental process work that we did to develop our task model to make it easy for administrators. We'll talk about that and how it benefits you. And then we'll actually drill in and do some demos and some specific examples of how the common management patterns help you to get acclimated to PowerShell. So the first thing I'm going to do is I'm going to kick off with a whiz-bang demo just to kind of give you a feel for what we're going to talk about today. So some of this stuff won't necessarily make sense until we talk about it in a few minutes. But even before I do that, let me get a quick show of hands. How many of you have been using PowerShell with Exchange 2007? Okay, that's pretty good. I'm impressed. How many of you feel competent and comfortable with using PowerShell with Exchange 2007? That's not quite as good, unfortunately. So we'll try to remedy some of that in here. So up on the screen here, fortunately, is my demo machine. So let's just run through, and I'm going to whiz-bang hit a couple of topics here quick, and then we'll go back to the slides. So the first thing I want to do is introduce you. This is the Exchange Management Shell. This is an overlay on basic PowerShell that we provide in Exchange. And basically what we've done here is we've given you kind of a welcome screen that gives you some quick getting started hints. And additionally, it actually lets you have some things like the Exchange commandlets loaded by default into the environment and some profile settings to help set up the environment in a way that helps make Exchange easier. So when you actually fire up Exchange Management Shell, it'll look a little different than the PowerShell environment, but it's still just PowerShell. So we've got a couple of great quick tips here to get you started. What we can do is we can show you the same objects that you're familiar with from Exchange 2003 still exist in 2007. So let me run through and show you. We've got commandlets to manage some of these things. We've got get Exchange server. And I'm giving away one of my things here with tab completion. But get Exchange server. This is the concept of an Exchange server, right? We're familiar with what Exchange servers are. They have some properties. We can do get Exchange server. Okay. We've got get storage group. Get storage group. Type the whole thing out. And get storage group. Everybody's familiar with the concept of a storage group. We can get the storage group object back, and it has some properties associated with it. Okay, storage groups contain mailbox databases. Okay, so we'll do get mailbox database. We can return objects that represent mailbox databases in PowerShell. We have mailboxes. Everybody's familiar with mailboxes. It's the fundamental building block of the Exchange system. So we'll say get mailbox. You see there's a bunch of them. They're scrolling by on the screen. Each of these is an object returned from PowerShell from the get mailbox commandlet. There's 500. It may take a second here to scroll out. And then we can do some cool things that PowerShell gives us. Right? In PowerShell, there's some built-in commandlets. We can do things like get mailbox, and we can use the built-in group by database. Right? That database is one of these properties here in a mailbox. We can say group by database. Now it's going to return all those objects, and we'll group them by database. So what it's doing is returning all those objects, piping them to group by database. We see there's 3 databases, gives us a count. Pretty useful. Okay. We can do some even more complicated stuff. We can say get user, we can sort it by company, and let's say we want to actually format it as a table in the output, and we only want to show, let's see, name and department and company. Penny, okay, so this is actually getting all the user objects using the built-in PowerShell sort, and then outputting them into a table format with name, company, and department, I think was the third that I chose. So pretty cool, reformatting on the fly. We'll come back to all that, don't worry. So let me actually show you some other cool stuff. I've got a file on the disk here. I'll use the built-in PowerShell get content commandlet to get this file back called commission.txt. So commission.txt contains 6 or 7 names in it, okay? And these 6 or 7 names coincidentally map to some mailboxes that exist on the system. So I'm going to use this input from a file to help drive the next thing I'm going to show you, which is that I'm actually going to create a new distribution group. I'm going to use new distribution group commandlet, part of Exchange commandlets, and I'm going to say, we're going to say it's the goals commission, C-O-M. Are there 2 M's in commission? C-O-M. I don't think that's right, actually. I-S-S-I. We'll make 2 M's in commission. I apologize if that's wrong. I-S-S-I. And what we're going to do then is we're going to say it's a type of distribution group. Distribution group. And what we're going to do is give it a SAM account name. SAM account name of goals. And we will say that it's an organizational unit. IGA, okay? And it didn't work because distribution group. Because I said distribution. See, this is proof that PowerShell protects you from things, right? It won't create a non-existing type. So let me go back and make this change. It has nice clear error messages. It tells me that the problem is I didn't select one of the valid types. I actually said distribution group when it should have been distribution. So now it'll work, hopefully. And then we'll have a distribution group created. Okay? This distribution group is a normal AD group that's been mail-enabled of type distribution group. So now what we're going to do is, given that commission.txt file, I'm going to go back and do the get content again. Content, commission.txt, so same 7 names or whatever. I'm going to actually pipe that into a commandlet that will actually add to the distribution group membership. So we have add distribution group member. It's going to take the input from that get contents output, and I'm going to say that the group I want to add to is the goals commission, G-O-A-L-S. So now what I've done is I've piped those names in. So now when I look at my get distribution group member of goals commission, I've added those 7 people as members to this distribution group, just like that, from a file. Okay, pretty cool. A lot less clicking than in the GUI, for instance. Let's do a couple other things here, and then we can show you the whiz-bang bit of this demo. So I've got that distribution group loaded with people. So I'm going to start using the membership of that distribution group as a criteria for doing some other actions. So every time I say get distribution group member, I get this list of 7. So I'm going to pipe that list of 7 into a set mailbox commandlet. So when I say set mailbox, and I give it some property on here, so we'll say we're going to do issue warning quota. We're going to manage the quotas here. Issue warning quota, 2 gigabytes. We'll come back to talking about why I can just type 2 GB. It's pretty cool. And then we'll say prohibit send quota. And we'll say 2,500 MB. Okay? So what I've done here is I've said, get these 7 mailbox objects that are members of this group and set some quota stuff on them. Right? They deserve special quotas because they're part of the goals commission. All right. So the next thing we'll do is we'll actually do some additional manipulation on this set of objects. So we'll get that membership in goals again. And we'll say get mailbox for each of them. And I'm going to build this iteratively so you can see what I'm doing as I go. There's our 7 mailbox objects. I'm going to sort them. Oops, up arrow to get that back. I'm going to sort them. And I'm going to sort them by their custom attribute 6. Custom attribute 6. So now they're actually sorted in order of their custom attribute 6, which isn't on the screen here, but they have one. And I'm going to get mailbox statistics for each of these. Okay, so mailbox statistics is the store mailbox object data that gives you mailbox sizes and things like that. So I get mailbox statistics for each and every one of them. So I'm going to get back 7 mailbox statistics objects from the store. And then I'm going to actually show you kind of a cool whiz-bang thing. We've got out.html. So out.html is a script that takes as input some objects and writes as output an HTML representation of those objects. So There's actually convert2 HTML that ships with PowerShell, but this is just one we've written because it has some extra formatting in it. So the out HTML is going to take the input of that stuff that was just dumped to the screen there, and it's going to write it to an HTML file. And then it streams it back out on the pipeline. So this is that HTML file. Looks great, doesn't it? Right? Well, that doesn't help you at all, right? But if you actually wanted to, you could use the out IE script, which takes as input HTML stream and dumps that to the internet browser. So out IE, we end up popping up an Internet Explorer that has all this stuff nicely formatted. You can adjust the formatting. Pretty powerful. You saw it took 2 minutes, right? So you can scroll down. We got all those objects in there. All right, one more quick whiz-bang demo here. Let me delete back here a little bit. We'll change it up a little bit. Instead of doing a sort this time, we're going to do a group. So we'll do group on custom attribute. Custom attribute. Custom attribute. Attribute 11. Okay, so now what we've got is the members of that commission grouped by their custom attributes. Okay? What we'll do then is we will actually use another script that I've got here for the whiz-bang demo called outChart. And what outChart is it takes input objects, in this case this grouped set of count, name, and group, and then what it does is it actually pivots and builds a JPEG chart using the OWC components to actually give you a graphical chart on axes of these two things. So we'll say the two axes we care about are name and count, because we really just want a representation of the number and which category it's in. And what that should do is it should give us a graphical representation. This is a JPEG on the disk, and it pops it up because we're telling it to make it visible. This is a graphical representation of that data that we've got there. So we can put it in a web page, we can put it in a web browser, we can put it in a graphical chart, you can put it in whatever you want. And that's sort of the fundamental thing that I want you to get from this quick scripting introduction demo. Right, we'll come back and we'll drill into all the different things I was doing there on the commandlets and whatnot as we go through the rest of the talk. So let's jump back over and look at the PowerPoints again. So that's the scripting introduction. Oops. So let's talk about the basics again. Right? What's PowerShell? Well, so PowerShell is actually a couple of things, right? It's, from my perspective, we say it's an extensible scripting technology, which is interactive, programmable, secure. We'll talk about what that all means here at the second half of the slide. But it's a product, among other things. It comes, it's separate from Exchange. It provides some additional cool stuff into Exchange that we never had before, right? It improves our developer experience because it's essentially a wrapper for .NET. It gives you a command line mechanism for accessing .NET. Okay? It also improves the administrative experience. Okay? What it does is it enables IT pros to write secure automation scripts. We'll talk in a little bit later on about VBScript and about how some of this stuff has sort of existed for a while, but you'll see that PowerShell provides a unifying force for all this and really makes it a lot easier. But the goal here with PowerShell is to understand that it's a developer benefit and an administrator benefit. So what makes up PowerShell? We've got the scripting language. So everybody's familiar with PS1 files, and you can write commandlets into a script PS1 file. An interactive shell. Okay? This is fundamentally great. When you write VB scripts, it's pretty hard to get an interactive shell there. We can actually do iterative script development in PowerShell because of the interactive shell. I'll demo some of that a little later on. Some domain-independent utility commands. That's sort, that's group, that's get process, that's get command, a bunch of the stuff that PowerShell as a baseline provides. We can make use of it because we live in that PowerShell space. And a way to produce task-oriented commands. That's C# commandlets that Exchange team wrote, run inside the PowerShell engine. Right? So other teams can extend, they can write their own commandlets. You'll see a lot more commandlets coming out of Microsoft over the next couple of years. And actually, I should have a very bottom bullet on that slide. There's PowerShell version 2 that they've introduced at, I think, last week at the dev part of the session, dev part of the conference. So the PowerShell team has a lot of great sessions on PowerShell v2 that they're talking about this week. We won't really talk about it in here because in Exchange 2007, we have a dependency on PowerShell v1, and since PowerShell v2 is still beta, there's not much we'll do with it with Exchange 2007 in the near term. But definitely, apart from your Exchange experience, if you think PowerShell is really cool, take a look at PowerShell v2. They're doing a lot of cool stuff in there. Remoting, script command. There's some great sessions. I encourage you to check it out. So key PowerShell concepts. So at least from an Exchange perspective, the key unit of operation is a commandlet. So all of our Exchange functionality is exposed with commandlets that have names to them, like remove something, new something, whatever. Commandlets are .NET classes, not exes. So that means that you get the benefit of .NET, right? You can actually look at them as .NET objects. And all of our Exchange operations are PowerShell commandlets. There's, sometimes I get questions in these sessions, why don't you use providers, et cetera, et cetera. There's reasons for all that. We can talk about it after the session, but commandlets are the Exchange unit of operation. So namespace providers, there's a couple that come with PowerShell. File system provider, that's obviously everybody. If you use PowerShell, you're living directly in the file system provider by default. That's where you dir, that's where you get content. There's registry, local certificate store, alias provider. There's a bunch of them that they provide. Pipelines. We'll come back to talk about pipelines in a little bit, but pipelines are pretty cool because we do pipelines differently in PowerShell than is traditionally the pipeline experience. We pass rich objects in pipelines in PowerShell. We don't pass strings. And of course, they provide the extended type system that helps you actually do you can extend the objects. They're not just limited to the base .NET stuff. So it's pretty cool. Exchange 2007, side by side with the old way of doing things. Okay? So in 2003, if you wanted to get information on how big your mailboxes were, there was a way to do it. It actually wasn't even that hard. It's only 20-something lines code here. We can call in and we can do, what is this? It's like a WMI connection here. We can grab all this data. We can extract all the things, put them into strings, output them. You end up with roughly the same output, right? When you look at it, it's the list of properties. In 2007, our PowerShell one-liner, get mailbox statistics. Maybe target it to a server if you're not already sitting on the server. Now, side by side, it's obvious that the 2007 implementation here is easier to use. But what's cool is that it's actually a lot more powerful, too. Because remember, I said we get objects back. We don't get strings back. So that means that in the VB script example on the left, not only have you written 20-something lines of code, but at the end of it, you've got a string outputting to the VB script host. You don't have any richness there. If you want to reformat the way this reads, if you want to make it say, if you want it to be last logged on user account equals equals as opposed to equals, you'll have to go back and change your script. In the Exchange 2007 world, you get back a set of objects, and that set of objects can be transformed however you like on the pipeline. That's the examples that I gave you where we were putting it into HTML, we were putting it into a chart. You got objects that you're dealing with in 2007. Very, very powerful. The other two examples here we'll breeze through pretty quickly, but you can just see you have to do lots of craziness. We're having to connect to LDAP. We're having to understand the distinguished names that we're looking for. There's none of that complexity in 2007. We let you actually reference things by simple, easy names, and then we let you take powerful actions to transform and consume those objects. So let's talk about the architecture here a little bit. This is the enhanced version of the slide we talked about at 1:30. So we'll go bottom to top here instead of top to bottom like we did in that session. So starting at the bottom, historically in Exchange, we have always had just a number of different data stores where our data is kept. So from a configuration data standpoint, there's at least 4 important stores that we constantly use in Exchange. We've got the MAPI store. That's knowing if a mailbox database is mounted, knowing how big a mailbox data is. Registry. Okay, we got a bunch of stuff stored in the registry, of course. The AD is the key store. That's where almost all of our configuration lives. And then the metabase for a lot of the IIS and virtual directory related stuff. So in 2003 and previous, we could access these things, and a lot of them had programmatic interfaces. It was not uncommon to be able to write VB scripts using WMI to get access to these things. You could use the native ADSI providers, etc. But one thing that we've done in 2007 that's super awesome is this very bottom level below where it says Exchange commandlets, it says configuration data objects. What we've done is we've developed these objects that are used within Exchange commandlets that are actually consuming and unifying this lower level. So when you want to think about a mailbox database, you don't have to care that 90% of it lives in the AD and 10% of it lives in the MAPI store. That's irrelevant, because when you consume that Exchange commandlet, you're getting 100% of that unified through that configuration data object. Okay? So that's pretty powerful. We unify all of our programmatic interfaces through Exchange commandlets based on these configuration data objects. So above the configuration data objects, we've got Exchange commandlets. If you've been using the system, you're familiar with all the commandlets. My demo a few minutes ago, all these commandlets exist, written by Exchange. What they do is they give you access to the business logic associated with those objects. So to use my mailbox database example, if I say new mailbox database, there's a set of constraints on how that mailbox database can be represented. There might be, the name might have a restriction. It can only be X characters long. There might be relational constraints. It has to be linked to some storage group as a child object, things like that. The Exchange commandlets embed all of that relational and constraint business logic, either in the commandlet level or in the configuration data object level. So an example of where this saves you time is if you're writing your code, you're writing some programmatic interface to Exchange, and you're using the Exchange commandlets, you don't have to care about validating a lot of this stuff because the data objects do it for you. When you were using ADSI providers, reading, writing with LDP, ADSI edit, or some programmatic interface against the Active Directory, you had to validate that stuff yourself or else risk things getting corrupted. The data objects protect you from all of that. Okay? A huge benefit. Makes it easier and safer to use the interactive shell as well. So one step above that, the PowerShell engine. Our commandlets play in that PowerShell space. So we make use of their parameter binding, we make use of their object, the way that their objects work, their type system. All that stuff comes from this external PowerShell product, and Exchange just inherits that goodness. So that's the same thing you'll see as more products begin to use PowerShell as their management playground. So that's where we stop for setup in the CLI. Our command line based setup and the CLI, they're all built on PowerShell and commandlets. If you want to go up through the GUI, however, we actually built an additional layer, the PowerShell data provider, because we wanted to be able to do a couple of things efficiently in the MMC GUI that were not inherently in the V1 PowerShell design. For instance, that's kind of 2/3 to the right side here, the Windows Forms ADO.NET. Through this PowerShell data provider, we actually have an ADO.NET interface so that we can do some really standardized kind of ADO access to get back rows and rows of data tables that represent the objects underneath. So when you look at the Exchange GUI, and it's small, I apologize, and that's probably all we'll see in this deck, but if you're familiar with the result pane, we get back potentially thousands, tens of thousands of recipient objects, for instance, in a result pane. We actually stream those up very efficiently from PowerShell objects through our ADO.NET provider. Okay. The very far right one, the Windows Forms for early bound objects. When you double-click on an object, you have the context of that object from that ADO.NET result pane. We can actually get the full object back and represent it into a property page using the early bound object portion of our data provider. And that's how it works. The key part of this whole slide, though, is that no matter whether you end up at the GUI or whether you end up at the setup or the CLI, beneath it all is PowerShell and Exchange commandlets. So the legacy that we had of GUI that was written with code in the GUI that complemented or detracted from programmability interfaces in the scripting level, that's gone. 100% is at the Exchange commandlet level, and then it trickles up through the GUI from there. So it gives a lot of, it's a new paradigm, but it gives a lot of power to the GUI and to the commandlets. So the task model, how did we come up with our set of commandlets? If you look at the Exchange commandlets that you get from the Exchange management shell, it's a fun exercise. Do get command and filter on the PS snap, or do get X command for the built-in function that does that for you. You'll see there's hundreds of them. I actually probably should know how many there are, but I've lost track. There's 300 something probably. And the reason why is because we have a lot of objects and a lot of things you can do on those objects. Well, what we did when we were moving from 2003 to 2007 is we stepped back and think about what's the best way to make the administrator's experience better with PowerShell. The legacy scripting that we had with VBScript and that we had with WMI and that we had with CDO-EXM and all the other interfaces that were out there, it was pretty awkward. It was very dev-centric, right? You had to understand a lot of things that weren't really native to somebody who's primarily an IT pro administrator. Well, the task model for us actually allows us to go in there and think about what is an administrator going to do? What do our administrators do in 2003? And then we, based on that, came up with some groupings and modeled all of those actions. And that's how we developed our object model in Exchange 2007. Was by inventorying all of these operations into groups of task behaviors. So you'll hear people in Exchange throw around commandlet, and you'll hear them throw around task, and it's roughly interchangeable, and it's because all of our commandlets are modeled on task behaviors, the things that you do in your daily job as an IT pro. So there's some categorizations here that we'll demo in a little bit, but the key thing is to understand is that we actually have thought through end-to-end the behaviors of our IT pro admins for this model. 375 commandlets. Should have waited till the next slide. So we cover all aspects of Exchange management. We cover everything you can do in Exchange, and then there's some touch points with other things. We cover a little bit of AD, we cover a little bit of IS, but we try to do it only in so much as we need to do those things from an Exchange perspective. Recipient management is newly moved into the Exchange management scope. We used to have the Active Directory users and computers tools, and you could do your management there. We've moved that into the Exchange management console and into the management shell so that all that stuff can play in that automation and PowerShell space as well. Organization settings, some examples there, server settings, and diagnostic, a bunch of things that MOM or other management monitoring tools can use, BPA. We have a pretty good coverage. 375 commandlets is a lot. I think PowerShell has 120 or something out of the box, so we have a lot more functionality, I guess, to represent than they do. So the next thing we'll do is we'll actually talk about .NET objects. This is a demo at a slightly lower level than the rest of it in terms of Exchange, but let's flip over and take a look at, let's flip over and take a look at that. Close out this chart. All right. So I mentioned that PowerShell really wraps .NET and gives you access to a lot of power from .NET. So we'll look at a couple of cool things here. And first of all, let's go ahead and populate a variable. So we'll do $DL equals get distribution group. We're going to load up that distribution group that we created before into a variable. So now if we look at this variable, that's the distribution group. Same thing as typing get distribution group each time. All right, let's look at all the properties on there. You can see by default, it shows you these 4 properties. But there's more properties than that on the distribution group. If you go into AD and look, you'll see there's probably 30, 40 properties in AD. Well, we've actually got the 30, 40 properties here. Okay? We just hide them. This is another example of trying to make it easy, safe, fun. We make it the most common things you might care about as the default display. If you want to see them all, they're all there. Okay? So let's actually grab one of those. So we'll do another variable, dladdr equals, and we will grab $DL dot, okay, this is, the pinky toe into the programming world here, dot primary SMTP address, which is on the screen here about 2/3 the way up. And the primary SMTP address will actually go one step further and dot that one with a toString, the function that's associated with that property. So we're going to end up with a variable that has the string, in this case, goals commission at lfp.es. Okay? And what we'll do then is I'm going to show you that we can actually get all of our distribution groups, just to show you the way an array would work here. So I'll create another variable, and we'll say get distribution group. Okay? And now we actually have 3 distribution groups. Right? Before I actually gave the name, so it only returned the 1. But now what I've done is I've loaded up a variable as an array with 3 entries in it. Since it's an array, we can actually index into it. Right? Pretty powerful stuff. It's, that toe in the water of programming languages here, right? All right, so let's actually show you some .NET functionality. So I'm going to create a thing called an SMTP client variable, and what I'm going to do is, instead of dumping a distribution list or something in there, a string, I'm actually going to do a new object. And my new object, I'm going to actually make this an object of type system.net.mail.smtp client, and I'm going to give it some parameters. Okay, so now what I've got, this variable has been loaded up with, oops, type the whole thing, don't I? It's been loaded up with a rich .NET object, and I've instantiated an SMTP client with the host of E12 and the port of 587. Okay? So this is a .NET object and a variable. Keep that in mind. So what I'm going to do is I'm going to get some credentials, because we got to have credentials, right? No anonymous relay. So we'll say credentials is get credential. And I'm going to say we'll get credentials for the xadmin user. So I'll say it's E12 dom/xadmin, and we'll give it the password. Hopefully that is the right password. So now you see I've actually got a rich credential here as well with a username and a password from the get credential. So I'm going to take those credentials, put them on the SMTP object. So $SMTP client.credentials. And I'm going to say that that is $cred dot get network credential. Work credential. Okay. So now my SMTP client has been loaded up with the credentials that I input. Okay, that's great. So finally, let's use that SMTP client to send something to port 587 on the E12 server using those credentials. Do .smtp client, and we'll say .send. Okay, another function on this .NET object, and we'll give it a from xadmin at lfp.es, and we'll give it a 2 of the dladdr that we created before. That's the SMTP2 string that we did before. And then we'll say the subject is welcome, and the message, since it's a lot of typing here, I'm just going to make it a very simple message. We'll say new list created. We created that new goals commission list. We're sending an email to it. Okay, so what I'm going to do now is I'm going to hit enter and cross my fingers and hope that it sends. Okay, so went ahead and it did the function, didn't give me any errors. Well, we can double check and see if it's sent. Let's do that. We've got a commandlet called getQ. And if I do getQ, it shows me that there are 16 messages in my queue. Whoops. Okay, so we know potentially at least one of those is a message I just sent, but there's some other ones in there as well. Well, let's drill a little further. We've got getMessage. Okay, this is another exchange commandlet. And the getMessage commandlet will show us a little bit more about the messages that are currently on my system. You can see the very bottom message there, from address, xadmin, subject, welcome. So that SMTP client, using .NET directly from PowerShell, did send that message. It did dump that into my submission queue on the server. So now, interestingly, we have a queue viewer that's in the GUI, right? Our queue viewer in the GUI, we spent a lot of time on it. It's real pretty, shiny. You could build a queue viewer here in PowerShell, right? We've got the tools. We can see the messages, right? And we've got this cool PowerShell programming-ish environment. Why not just build a queue viewer here in PowerShell? Let's do it. Simple one, right? We do while true, so we're just going to loop until I break out of it. We'll clear the screen. Otherwise, it would look kind of silly because it would just keep scrolling down. And then we'll say getMessage. And we'll say queue E12 submission. We only have one queue right now, but if there were more. And we'll pipe it to FT to make it a nice table output. And then what we'll do is we will loop on that with a sleep of 1. And then we'll close the function. And I only need one of them there. Okay. So what we're doing here is we're looking at the queue. And every second it clears the screen and looks at the queue. And every second it clears the screen and looks at the messages in the queue. That's our queue viewer here in PowerShell. Right? Not quite as fancy as the one in the GUI, but you make do. So let's talk about a couple other things, and we'll come back and look at this queue again. So let's talk about aliases. Aliasing is something that PowerShell can do that we make a little bit of use of. You might wonder about CLS, right? I type CLS, it clears the screen. Well, CLS doesn't sound like PowerShell, right? Well, it kind of is, right? Because it comes with PowerShell. But what is CLS really doing? Well, if I do getAlias CLS, it'll tell me that what CLS is doing is clear host, right? So that's a PowerShell commandlet, clear host, and they've aliased CLS to it. Lots of aliases that come by default for free with PowerShell. dir, CLS, FT, FL, lots of great time savers that you can not have to type as much. So let's look at some other ones, right? We've got alias, right? Shows you all the aliases. Say alias group. Okay. You could say alias. It doesn't exist, right? So we can say alias. I already showed you CLS, and I showed you group. Okay, so let's talk about functions now. We've talked about aliases. So functions are another built-in PowerShell thing that's kind of lower level than Exchange, but pretty helpful. What functions let you do is they let you wrap up some of your code and make it reusable within the PowerShell host. So we'll create a function called showQueues, and I'm going to wrap that queue viewer that I built a few minutes ago into a function called showQueues. So we'll do function showQueues, and we'll say it's the exact same thing I typed before. Well, $true, do the CLS get message queue E12 submission, and pipe it to FT to make it pretty, and then clear the screen. And actually, we don't need to clear the screen, we need to sleep. Clear the screen at the beginning. All right, so we end up wrapping closed our internal function and wrapping closed the internal script block, and then wrapping closed our function. Okay? So now when I've done this, enter. Now I've defined a function of showQueues. Now I no longer have to type that whole silly thing out. I can just say showQueues. And it's my same queue viewer from before. right? So this is kind of cool. If I really wanted to use this as my Q viewer in PowerShell because I thought it was the coolest thing ever, or if I developed some other function that was pretty cool, I could just add this to my profile, and right away, every time I go into PowerShell, I'll have this available by typing a short little thing. Okay? So any repetitive stuff you do, that's a real time saver. All right. And we're not going to demo that, so let me skip back. Back in the PowerPoint deck, on the other machine. Let's talk a little bit more about Exchange now, right? There's a couple of cool things that you can do that we've actually made sure to fill in from an Exchange perspective. So one of the common things that people used to say to me, not as much anymore, but when we first were in beta and we first were public with Exchange 2007, we used to get lots of feedback that it was hard to find commandlets. I can still understand how that might be the case. 375 commandlets is a lot to wade through to find out what you're trying to do. So we've got a bunch of things that help you actually find the right commandlet to use. So some examples on the screen here. Get help. The get help commandlet is really useful because it can take additional information. What do you want to get help on? Star user star. Anything about users. We have defined, remember I said before that we did this task analysis and we sliced and diced by role and component and all these other things. You can actually get all of the help for commandlets that are of a certain role. So if you care about the unified messaging role, you might say get help dash role star star. So the benefit of this is that if you say get help star, you're going to get user, set user, anything else that has user in it anywhere in the name of the commandlet. But if you say get help role star you get all of the commandlets that have to do with the role regardless of what they're called. You know, if there was a commandlet called get not actually related to unified messaging, or actually it would be related to unified messaging, and they spelled it out, the role would actually encompass that. So if you did get role star, it would find that commandlet. There's some pretty cool examples of this in the demo. And same thing for components, recipient-related commandlets. The help pages can actually help you understand how commandlets work. So once you've found the commandlet that you want to use, it's pretty straightforward to do get mailbox dash ? Or help get mailbox, help remove storage group. It'll give you additional drill down information on that commandlet, example parameters, some examples of the syntax of the commandlet, explanations of what the parameters mean, etc. You can explore the properties of output objects using format list. So by default, remember when we did that get distribution group, it showed us 4 properties in a table view. But then I did pipe it to FL, format list, and piping it to FL, it gave me the whole object. I got to see all 30 properties. So you can really understand what properties are on these things, what properties are available to you to use programmatically in your scripts and your one-liners by looking at the format list. Get mailbox, test user, pipe it to FL star quota star. Format list is pretty powerful, right? You can take wildcards and you can say anything that starts or ends with anything and has quota in the middle, right? So this is useful. We can see all the quota properties. And the last one on the slide here, explore the property types of output objects using getMember. If you want to know more than just what the properties are and what the values are associated with those properties, you can use getMember, which is a built-in PowerShell commandlet, just like format list, that tells you the type information about each property. So you'll realize that this property is a string, and that property is a database object, and that property is a date time, that sort of thing. It's pretty useful. Identity. So in Exchange 2007, one of the earlier slides, I indicated that in the old way, we'd have to know distinguished names, and you'd have to do all this ADSI : / and distinguished names with commas and CNs. That was the way we used to have to reference objects. In 2007, we don't need to do that. In 2007, all of our objects are uniquely identified by name or GUID, or you can use DN if you really want to. But we do a couple of things to make it so that you don't. So there's 2 types of objects that we have throughout the system. We have singleton objects, which generally, there's only one of them, so you don't need to identify them. You say get global settings, get transport settings. There's only one of these things. You don't have to say which one. But the much more common example is the multiple instance. Get mailbox database, get mailbox. We have hundreds, thousands of these things. So you need to identify them uniquely. And what happens is when you say new, in this example, storage group, what we're doing is we're providing a name. That's a mandatory property. And in the case of new storage group, that name is what's used to come up with that RDN in AD. So that's the name that is used to identify that last part of the distinguished name. once the identity is created as part of the new, you can actually reference it as an identity using any of the identity types, right? So here we say set storage group identity SG1. We're using the friendly name. We could also say identity the full DN with commas and CNs and equal signs. We could say identity the GUID that happened to be associated with it. Lots of flexibility. But mostly you'll probably use the friendly name, and that's why we have it. So notice that identity uses a URL-like scheme to help locate objects. So some of our objects are nested, right? We have servers, which contain storage groups, which contain mailbox databases. There's a hierarchy there. And we let you make use of that in your identity usage. So for instance, we'll see some of this in the demos. You can do some pretty cool stuff with wildcards and identities in a hierarchical sense. So in the last comment here, you can use GUID or DN if you want. Maybe there's a reason why you'd need to do that. I think particularly for interactive PowerShell, you probably won't do much of that. So finding things, searching, right? So in general, when you're in PowerShell and you say get something, we're going to return all instances of that object. So if you say get mailbox, it's going to give you all your mailboxes. That's not strictly true. We have some, result size limits that you'd have to override to get all your mailboxes potentially. But say you say potentially get transport servers. You have less than 1,000 of them, it's going to get all of them. Okay? What you might want to do, however, is take action or build a report against only some of the objects that are in your Active Directory. So in this case here, I want to know which transport servers have message tracking enabled or not enabled equals false. So perhaps what I want to do is I want to build a report that I can send to my management that says these servers aren't configured right. We need to reconfigure them during our next change window. Or maybe what you're trying to do is you're trying to actually make that change. You want to get all those servers that are not right and make it right. So you can do client-side filtering in all cases against the properties of an object that's returned to you in PowerShell. So you can say, get all the objects where on that object message tracking enabled is not set to true, it's equals false. You can do some wildcarding even without doing a client-side filter. You could say get mailbox star Joe star. Okay? There's a bunch of different ways that you can use wildcards. We'll do some demos there. In SP1, one of the fundamentally key cool things that we did for people that have lots and lots of objects is we removed that 1,000 result limit when using wildcards. So prior to removing this limit, if I said get mailbox star Joe star, and I had 1,001 Joes in my organization, it would tell me, oh, sorry, too many objects, be more specific. We've removed that. We now actually do paging on those results. We'll return all 1,001 of your Joes. Server-side filtering is provided for tasks that return large number of objects. We'll do a side-by-side. You can see the difference between how they work. The syntax is similar, but the performance is substantially different. So let's talk about how this stuff works. Let's actually jump over and show you how some of it works. All right. So let's look at the help. That was the first part of this. So when I say get help, and I do star q star, UE star, it's going to go ahead and it's going to run, and it's going to find all of the Q wrapped with wildcards, and it's going to return those to me. So now the interesting thing here is that it's returned me, in this case, 4 objects that have Q in their name, and it's returned the synopsis, which runs off the screen. So it's not really useful in this context. You'd have to probably actually format it so that you can see the synopsis, et cetera, et cetera. But there's easier ways. Let's say that we actually want to look at get Q specifically. We could say help get Q, and then we actually see the synopsis and the syntax and all the other good details. So that's how you might get that information. So let's look at the additional slicing and dicing. So we've got get help, and we'll say component, and we'll say queuing. So this is not Q-E-U-I-N-G. Actually, let's find it like this too. This is not looking for things that have Q in the name. This is looking for things related to the queuing component. So in this case, we see not only the 4 get Q, remove Q, suspend Q, we actually see all the message commandlets as well. Remember when we were doing our PowerShell Q viewer, we were using get message and get Q. They're related to that same component, just from different perspectives. So because these are all related to the queuing component, they all show up here, even though that's not part of their name. Kind of useful. And I showed you get help against suspend Q. We'll do this time instead of get Q. And this actually drills in with more of the detail. And it says here at the end, get help suspend Q detailed, get help suspend Q full. Gives you more or less detail so that you don't get 30 pages of parameters if you don't want them. And one last way to do it, you can do resume queue with question mark. And that's the equivalent of the get help. It just gives you the basic set of help for that commandlet. So let's look at the membership. Remember I said get member lets you understand the types of the properties? We'll say get queue. We'll pipe it to get member. And what this is doing is it's returning the objects, the queue objects, and then it's actually cracking them open and telling me what's the type of the object overall, this top line right here, and then what are the properties on that object and their definition, their type. Right? So you can see lots of, convert methods and things, and then a bunch of properties, right? Is valid, the next hop retry time is a system nullable date time. So this is pretty cool. It's pretty useful to understand what's the data I'm getting back. And particularly where this is useful is if you want to do cool stuff with it, right? Date time is smarter than a string, so you can do some cool stuff with date time. So very cool stuff. Get member, built in from PowerShell, lets you understand what you're actually dealing with at the object level. Okay, so let's talk about identities a little bit. So if I say get mailbox, like I demoed this actually at the very front, it just goes ahead and returns, I've got 491 mailboxes, it's going to return all 491 of them, no filtering, nothing fancy about identity. Well, each one of these mailboxes has an identity, so I could go ahead and I can say get mailbox, and we'll do Ronaldinho, and we'll say, his alias is Rona, I could just say get mailbox Rona, very easy, right? I've specified a specific identity and I've gotten back that object. I can also specify that identity by the primary SMTP domain name, right? So email address returns the same object. That's a second way of specifying his identity. I might say get mailbox, and maybe I want to use the domain notation. So I'll say, his SAM account, right? It's Rona in the E12 DOM domain. Same thing. Let's go ahead and actually I'm going to save off and show you another way that we can get his information, his mailbox. We'll say mbx equals get mailbox. So it's the same thing we did before, except instead of putting it into the pipeline, I've now put it into this variable. So what I'm going to do then is I'm going to say another session variable here. Identity. So remember I said identity is this characteristic, this property on the object. I can actually reference that identity directly. I'm going to save that identity into my $A variable. So now my $A variable contains the different parts of identity for this mailbox. You can see there's a bunch of them, right? Parent, dep, distinguished name, GUID, a bunch of cool ways you can reference this thing, depending on what aspect you need to reference to get it. So what I'm going to do then is I'm going to grab $A.distinguished name, right? I don't want to type this whole thing out, right? For my demo of showing you how I can reference it by distinguished name, I don't want to type the whole thing. So what I'll do is I'll actually use this programmatically to look him up. So I'm going to say get mailbox $A.distinguished name. Okay? So there I've actually passed in the distinguished name, the whole thing, commas and CNs and equals and all, and it's found the object as an identity component. All right, a couple more. So get mailbox. We'll say -database. So on get mailbox, we've got this concept of relationships I mentioned where the mailbox database is part of a storage group, is part of a server. So get mailbox -database, we could say the server is E12 and top 10. Okay? So the database that I'm specifying is one of the 3 databases on the server called top 10. So these are the top 10 teams and the players. So let's be a little more specific here. We can actually say get mailbox, and instead of saying -database, actually get mailbox database. So instead of saying get me all the mailboxes that are on the specified -database, let's just get that database. So get mailbox database of E12 top 10. So this is returning that mailbox database object, which then has a storage group in the server. So we can drill a little further. We can say get mailbox database. And we can say not E12, we'll just say top 10, because we assume, I happen to be sitting at this machine here, we assume the local machine, given no other context. So we'll say top 10, finds the top 10 unique database in our organization, and returns it. Didn't have to specify a server. Or I can go the other way. I could say get mailbox database, and instead of not specifying a server, I could specify a server and a storage group. Right. So that's the same thing. I'm referencing the same object each time, but you can see the identity here is very flexible. Depending on what information you have, if you have enough information, you can get that object back to take action on it. So one more thing here to show you, get mailbox. Mailbox dash organizational unit. And I don't think I actually mentioned this at the beginning, but if you've noticed, I have either been really typing super fast or I've been doing something else. I didn't type organizational unit here, I tab completed it. So tab completion exists for commandlets and for parameters. It's super useful when you have to type organizational unit. Okay? And there's some much longer ones even, so tab completion works. So organizational unit, and we'll say LIGA, since that's the organizational unit where all these mailboxes are. I am now getting back all of the mailbox objects that live within that organizational unit. So if I have done administrative segregation based on organizational unit, I could make use of this to do some action on these people, some action on these people. Okay. All right. Couple of search examples. So we talk about wildcarding. If I do get distribution group member, and I'm tab completing there, that's why I jumped to one and then the other, say goal star, right? So my distribution group is called goals commission, but I've actually said, get me the distribution group memberships of goal star. It found the goals commission group and got me the list of members, the 7 members. I can say get mailbox, RO star, okay? See, there's a bunch of them. It's not just RONA, it's a bunch of them that match that wildcard. And again, if I had more than 1,000, now in SP1, it would have returned them all. I can say get mailbox. And remember a moment ago I did the organizational unit of LIGA. Now I can just do LI star. Okay, it'll find my organizational unit LIGA. It'll return it. Okay. The membership from it. All right, so let's do one that works and one that doesn't. Right. So I'm going to say get mailbox database. Mailbox database. I'm going to say star slash p star, this is Primera, star. So this gets me my 2 mailbox databases that are part of the storage group that starts with P. Remember, server slash storage group slash mailbox database. Well, what happens if I say get mailbox, and I say dash database star slash p star slash star? So what am I asking it to do here? I'm saying get me the mailboxes that are in the database, these 2 databases, because there's 2 databases that match that filter. It's not going to work, right? It only takes action on one of those objects. It's telling me you got to have a unique value there. So what can we do? Well, it's pretty easy. We can be more specific. In this simple example case, we'll say T star. So now we're only giving it one database. Now it's able to use that one database identity and return those objects. So interesting question, how would you do it so you could get all of them from both the databases? You'd have to iterate through it twice, and each time would do one and then the other. All right, so let's talk about client-side filtering versus server-side filtering. Okay? This is pretty cool because client-side filtering is a little bit more ubiquitous. You can do more stuff with it reliably because everything is exposed, always, but it's slower. And we'll see how that works. So if I say get mailbox dash filter, that is server-side filtering, and not all of our commandlets have this. This is an exchange-specific thing that we've implemented to optimize the LDAP queries. So if I say dash filter alias like, and we'll do a match against RO star, and we'll make it a complex query just to slow it down a little bit, and we'll say alias like, oops, dash like A star. So all of our people who are either RO star or A star with a server-side filter. Okay? So that's pretty fast, right? That's just the same as get mailbox in terms of performance. Didn't seem slower to me, at least. Let's look at the client-side filtering. Get mailbox. Now here we're actually piping all the mailboxes into where. This is the client-side filtering, where object. And we'll say that objects.alias is like RO star, or that object's alias is like A star, and close brace. Now, it's probably not massively slower because I think we're looking at 30 or 40 objects here, but even for 30 or 40 objects, you can see that the difference between optimizing a server-side search and a client-side unoptimized search is pretty significant. And the reason why is because the server-side search is saying, get me these objects only, whereas the client-side search is saying, get me all the objects and I'll take care of filtering them. So in particular, as you write one-liners and scripts, it's easier to do where clauses but it's going to be slower. So if you're doing thousands upon thousands of objects, take that into consideration. All right, let me flip back over. All right, pipelining. Now we're getting to a couple more complicated concepts here. So we can do some pipelining, right? Bulk management is possible in PowerShell, primarily with pipelining. And the way that works is that you take the output of one object, one commandlet, rather, some objects from that commandlet as the output, and you pass them in to the other commandlet. This is really the power of automation with PowerShell. I can do something like get storage group, which returns me a bunch of storage group objects, and then I can set storage group. So get me the 5 storage groups, set some properties on those 5 storage groups. It's very powerful. So when you're going within the same noun, like get storage group to set storage group, get mailbox to remove mailbox, 100% of the time we make that work because of the way we define identity. Okay? The identities are consistent within a noun. But we also have a couple of cases, sprinkled throughout the product, where it makes sense to be able to do cross-noun pipelining. The example here, get mailbox, pipe to test MAPI connectivity. Give me this mailbox, and then test the MAPI connectivity of it. Test MAPI connectivity takes as input a mailbox object through pipelining. And there's a bunch of those sprinkled throughout. Now, even in the case that you can't directly pipeline between 2 commandlets, for instance, let's assume that get mailbox didn't pipe into test MAPI connectivity for some reason, you can force it by extracting some property on the output object of the one thing and taking it as input into the other. Now, this is a huge thing, right? Because when you think of pipelining in, say, the traditional Unix scripting type sense, you're passing strings, right? So if you don't know what to do with that string, you're out of luck. But here, we're passing rich .NET objects between these commandlets. And so that means if I say get exchange server, I've got this multi-part exchange server structured object that has names and storage groups and settings and various other things that I can extract and use as either filtering criteria or as pipelining criteria. So in this case, I'm saying get exchange server, and then for each exchange server object that's passed through the pipeline, get the storage groups on that server. And I'm doing that by saying -server $_.name. So on that exchange server object that's my current pipeline iteration, get me the storage groups. So we iterate through all the servers and do that. So very powerful stuff. You can always do this. This is sort of like the client-side where clause filtering, except for pipelining. Preventing accidents. Remember before I said that PowerShell is safe, easy, and fun, right? That's kind of the mantra. We try to make it safe, easy, and fun by making sure you don't break things very easily. We try to protect you from the obvious things you might do wrong that would cause problems. Some examples of how we do that are we provide ubiquitous what if, confirm, and verbose parameters on the commandlets. So that means if you try some operation, you're not sure quite what's going to happen, which objects are affected, what's going to be the outcome, you can say -what if, and it'll tell you, oh, I would have deleted this object and this object and this object, but I didn't, right, because you did what if. So that's pretty useful for sort of simulating a script run. We've got confirm, which is turned on by default for destructive operations. So if I say remove mailbox, it's not going to just go ahead and remove it. If I say remove mailbox star, this wild card that covers all my mailboxes, it's not going to just wipe it out and, uh-oh, I'm in trouble. What it'll do is it'll say, all right, mailbox number 1, do you want to remove it? Yes, no. Mailbox number 2, do you want to remove it? Yes, no. It's going to prompt you for every single iteration of all 491 mailboxes. So that's good protection right there. You can turn it off if you want to. There are certainly cases where it makes sense to turn off confirmation. But by default, for destructive operations, it's turned on. And verbose, if you need to know more details about I'm talking to which domain controller or what's the thing that's actually happening. That's sort of like the tracing behind the scenes as you run a commandlet. Not quite as useful, but helps you understand what's going on if you really care to know. We also have, as I mentioned, in these data objects that we've defined to represent those lowest level data sources, we actually have validation logic that confirms that objects are valid before it lets you make use of them and change them and write them. So specifically, if you were to go in with ADSI edit and change some property that made it invalid by virtue of some constraint on that object, quote is a great example of this. The 3 quota values have to sort of stack in ascending order. You can't have the one quota be bigger than the other because it doesn't make sense to say you can't receive if you have more than a gig, but you can send if you have 2 gigs. It's weird, it doesn't make sense. So we have some sort of relational constraints between properties, and then we have constraints on individual properties as well. The maximum value for this is some number. These are the 7 enumerated values that make sense in this field. Things like that are actually in the product, and the validation logic takes care of that for you. None of the commandlets will let you set things into invalid states, but if you use ADSI edit, you can change things, and it'll be broken. But the benefit here is that PowerShell will tell you when it's broken and what's broken and why. So if you've got a broken object because it's been improperly provisioned outside of the scope of Exchange PowerShell, outside of the scope of the Exchange GUI, we're going to actually flag that for you and let you know that it's broken and how to fix it. So when you do a set operation to actually update that commandlet, we won't let you update that commandlet until you fix the problem. So if the quotas are out of whack, your set operation has to fix the quotas, or else it's not going to let you write. It'll fail the other writes. So we do what we can to protect you from setting invalid things on your system. So putting it all together, there's a couple cool examples here. So we've talked about the various commandlets, pipelining scenarios, properties. There's some cool examples of how you might tie all this stuff together. First one, get mailbox -server-server1. For each mailbox, what we're going to do is get the mailbox database. Okay, so all of our mailboxes, what's the database for each one? And then we're going to group them by name. So we end up with an outputted object that is a group object of mailboxes grouped by their database's name. Okay. Second one here, we're piping in the integers 1 through 5. So it goes 1, 2, 3, 4, 5 into the pipeline. And for each of those numbers, we're creating a new storage group named SG, the object in the pipeline. 1, 2, 3, 4, 5. So we get SG1, SG2, SG3, etc. on server-server1. And then we're piping each of those storage group objects into new mailbox database. So for each and every one of those 5 storage groups we'll create by iterating here, we'll create a mailbox database as well. It's great for provisioning. We'll talk in a minute about how I provision this demo environment. So get distribution group, new employees. So we've got a distribution group of all new employees. We're going to pipe that to get distribution group member, crack it open and look at the membership, all the users that are part of that group. And then what we'll do is we'll enable mailbox -database, new DB1. So the way this might work is that if we have some HR system that's dumping users into the new employees distribution group every Monday morning, right after that we might follow it up by enabling a mailbox for each of those new employees. Okay? And the last one here is actually one I ran on my system at home. I was getting spammed. I wanted to know who by, so I looked at my message tracking log, got the message subject, found the subject of the spam I was getting, grouped it by client IP, where was it coming from the message tracking log, selected the name, right, that's the field that is the IP address, and then here's the cool one, right, NSLOOKUP on the object. So I basically iteratively called NSLOOKUP, and I was able to look up who's the host that's hitting me. Is it coming from China? Is it coming from US? Where is it coming from? This is an example of actually passing that data, the PowerShell data objects, to a system thing that has nothing to do with PowerShell. NSLOOKUP is just an executable. So very powerful stuff you can do by combining together these different operations. So one more quick one here, how you save dollars by automating everything. We talked about all these one-liners. So far, we've done nothing that was a script. Absolutely 100% of everything we've done in here was not a script. It was just a one-line operation, potentially several commandlets linked together with pipelines. Okay? You can take those one-line operations linked together by pipelines, and you can actually make them into sequential operations in a file, a PS1 file, and you've got a script. So in this example here, we're saying new storage group, new mailbox database, get some user information, set some properties on the mailboxes. We're just going through a bunch of sequential one-liner operations that make perfect sense when you see them in isolation. We've got a script here. And this script is provisioning an environment and setting some stuff up for you. So when you think about how we write automation for Exchange 2007, the fundamental thing to understand is that it's not hard and complicated and confusing. It's that you just build one-liners that do some atomic thing that you care about, and then you put them together into a file, and that's your script. Okay? So I've got one more demo here to show you some automation. And I need to flip to the other box or you won't see it. All right. So in this automation demo, I'm going to do a couple of cool things with the pipelining. So when I say get mailbox database, I have to get mailbox. And That's going to show me, this is a cross-noun pipelining, right? I'm passing in a database, and then I'm saying get mailbox. And get mailbox is being really smart and saying, you only want the mailboxes that are on this database, right? So I passed in all the databases, so it showed me all the mailboxes. But if I'd specified a particular database, it only would have showed me the mailboxes on that database. It's the equivalent of saying get mailbox dash database, that database. Cross-noun pipelining. Say get queue, and I'll say the submission queue, so E12 submission, SSION. So this is our queue with 16 entries in it. So I'm going to look at the messages that are in that queue only. So get message. So that shows me, in this case, all 16, because all the messages are in there in the entire system. But what I'm going to do then is I'm going to look at only the one that's from xadmin. So I'm going to filter this down a little bit. I'm going to say get message dash filter. Again, this is server-side filtering. And I'm going to say from address. And notice since it's server-side filtering, I don't have to say the $_ because I'm not actually taking action on an object here. I'll say from address dash like xadmin star. Oops, got to spell it right or I won't find it. Admin star. Okay, so let's prove that this works. First of all, I'll see if I actually find the object. I do. Okay, let's look at all the properties on that object. Okay, so see, it has more properties than just the 5 that are displayed on the screen here. And this is a good time for me to mention the iterating again. So before I said it's really easy and helpful to use the interactive shell to actually develop your one-liners in your scripts. That's exactly what I've done here. See how I said get message dash filter from address like xadmin, hit enter, just to confirm what I was going to get. Then I hit the up arrow, added pipe to FL. Now I've got the next step done. Right? If I wanted to build this thing iteratively, I say, here's step 1, then step 1 and 2, then step 1, 2, and 3. This is the interactive shell really helping me develop my one-liners and my scripts. Okay? Pretty useful. So back to this. We'll say get queue, and we'll say E12 submission, SSION. So there's our queue again. And this time I'm going to say get message. We'll get all the messages in there again. I'm building iteratively here, rather. And I'm going to say group from address. Okay. Oops. Not get from address. We want group from address. See, it's so safe. It won't let me type anything wrong, especially in a demo. So group by from address. We've got a bunch of from addresses here, the bottom one being the xadmin. You can see that this Rafa Marquez has sent 3 messages, so he's pretty active. Let's say we'll sort them by descending. All right, so the next iterative step here is we'll say sort by count descending. So now we've got the 3 at the top. And let's say select, these are all PowerShell commandlets behind the scene here, select object. Select dash first 10. So we only care about 10 of them. We cut a couple off the bottom there. So in particular, if we had more than just one variant here, we would probably get more interesting results on sorting and cutting off all but the top 10. This might be useful for who are my top 10 biggest mailboxes, right? Instead of the queue size, you might pipe in a mailbox statistics. All right, let's do another one here. We'll say get queue, and we'll say E12 submission. So again, we're back at the beginning. We'll pipe that into get message. And actually, I've done some of this, so I'll just skip over it. Group from address. Pipe to, here's a little difference, for each. So now we're going to iterate on each and every one of these grouped entries, like you see just above. We're going to, for each, we're going to do get mailbox statistics. And we'll say that that's on $_.name. So the name field, the email address that's listed in that chart right there. Then what we'll do, let me show you that this works. Okay, so we'll pause here to show you the output. So what I'm doing is I'm getting each of these, I'm grouping them by from address, and I'm doing a for each get mailbox statistics for each one. Xadmin's never logged into his mailbox, so there is no mailbox object. Hasn't received any mail. But all the other ones have some mail in their mailboxes. So what we'll do now is we'll look at, we'll do a sort here, and we'll do a select to get first 10. All right, so this is exactly what I was talking about. What a great demo. I should totally do that one. Sort by item count descending. So you can see there is item count, the second column here. So now we'll sort them top to bottom, biggest to littlest. And then what we will do is we will select just the first 10. First 10. So now we're only seeing the top 10 biggest in terms of item count mailboxes. Okay? That's pretty cool. We can do some excellent cool stuff. We can then output this to HTML, output it to IE, output it to chart, whatever you want to do. All that transformation stuff is possible here because we're looking at objects. Okay? So let me show you. From before, we still have our queues up, right? So I'm going to do get queue again. Get queue. And you can see that there's 16 in there that are just sitting, right? And the reason why is because the status, let me show you here if I do an FL, the status of my queue is suspended, right? I held it so that there'd be some messages in there for this part of the demo. So if I do get queue pipe to resume queue, what's going to happen is I'm going to release that queue and it's going to start delivering all those messages that I've held in the queue for the demo. Well, let's watch those disappear. I've still got my show queues out there, so we can actually look at our queue viewer here. Queues. We can look at our queue viewer, and we can watch this queue drain gradually as those 16 messages become 3 messages, become 1 message, and now there's no more. Right? They're gone. They've delivered. Our queue viewer has served its purpose. Okay, some safety examples. Got about 5 minutes left. I'll try and rush through this so that we can leave, I'm sure, very little time for questions. I apologize. But we'll try and rush through this and show you the rest of the safety demos. So get mailbox. If I do get mailbox, and do r star, right? We get, oops, let's get mailbox. That's going to return all of my mailbox objects that start with R. And remember before I said if I just try to do disable mailbox, any of the destructive operations, mailbox, it's not going to let me just do it willy-nilly. It's going to ask me, you sure you want to do this? You sure you want to do this? I've got confirmations by default. So it's going to say, do I want to do it? No. Do I want to do it? No. Do I want to do it? No. You can say yes to all, no to all, whatever. But you know, the point is it's going to prompt me for each and every one. So I'll say no to all. It'll dump me out. Now what I can do is I can simulate that operation too. Remember I mentioned what if? So if I do -disable mailbox what if, it's going to say I would have removed this one. I would have removed this one. You know, disable mailbox this mailbox. Disable mailbox that mailbox. If I build out my whole script and the point of the end of my one-liner or my script is to disable all the mailboxes I filtered, I might want to do a -what if just to make sure that my list is right. You know, the CEO isn't the top person on the list. All right, so what else can we look at? Let's look at suppressing the confirmation. So if I say get mailbox and let's do R star, why not? We'll get rid of all these R star players, right? We'll pipe it to disable mailbox, and we'll turn off confirmation, right? Here's the danger, right? Confirmation false, and spell it right. So now what it's going to do is it's not going to prompt me, right? So this is a destructive action here. This is how you can shoot yourself in the foot. So it's going to go ahead and do it. It's going to get all those R stars, disable them all, and then dump me back at the command prompt. So now, if I do get mailbox R star, I've broken my broken my demo environment. But that's okay, right? Because what we can do is we can actually see all those disabled mailboxes. If I say get mailbox statistics, and we'll get all of the mailboxes that are currently disconnected, right? These end up as disconnected mailboxes in the store. So I'm going to say get mailbox statistics. We'll do a client-side filter on where the object.displayName, dash like R star. So here's all of our store objects. And you can see that if I pipe this out to a format, and I do formatting on display name and disconnect date, we'll do a wildcard that'll find it. You can see these are all disconnected, right? That second column there is when they were disconnected, 2 minutes ago or whatever. So what I can do is instead of actually just looking at this list, I can do a reconnect. We have connect mailbox commandlet, connect mailbox. And because we have display names and all the leg ends and everything match because I've just disconnected them, this should just go ahead and reconnect all of them by prompting me because that's a questionable operation. So I'll say yes to all. We'll let it just match them all back up against the AD. And then hopefully when it finishes, I can just hit the up arrow and we can do get mailbox R star again and I'll see that they're all reconnected. So hit the up arrow and whew, they're all back, right? And there's a bunch of other great demos that we absolutely don't have time for, so I apologize about that. But let me flip back over and we'll close out the slides. So, interestingly, my slides got switched. So there's one more thing let me talk about. I mentioned before that we're going to, so when I was doing the demo before where I showed storage groups getting provisioned with numbers and creating mailbox databases inside them, that's how I provision this environment, right? It's fundamentally important to understand that I didn't sit at my desk and type in 491 Premier League players into this environment this morning or yesterday or 3 days in a row. I haven't done that. What I've done, and actually let me flip back over and I'll show you on the demo box. What I've actually done is I've got a script here called generate.ps1. And what generate.ps1 does is it goes through and does lots of cool PowerShell one-liners, one after the other, and that's probably hard to see, and I apologize. But trust me, it's just taking imports from a CSV file that have all the data about the players, and then it's provisioning the environment and the players and the email address policies and the offline address books and all sorts of cool stuff from a script that is made up of nothing but one-liners and loops. Okay? And what I can show you here is that I have a second script called, what's it called, cleanup, I think. My cleanup script rips it all out again. So I want to prove to you that this actually works by ripping it all out again. So I'm going to say, oops, sorry, you see inside my Active Directory here that I actually have a organizational unit. And in my organizational unit here, I have this set of 491 objects. And what I'm going to do is I'm going to run this cleanup script. The cleanup script is going to rip that all out and clean up the databases, clean up the Active Directory, clean up the entire environment, just like it was fresh install of Exchange. Okay, so that takes a second, not too long, because we kind of rip it out harshly. But now having done that, we're going to go in here, and I will show you that all of those users are going to be gone inside my Active Directory users and computers. That's just removing databases now. So let me hit F5 here. That entire organizational unit is gone. Down here in this world, if I say get mailbox, I've only got the one, the administrator account. If I say get mailbox database, just got the one. It ripped out the top 10 and bottom 10 that I had segregated before. It's gone, fresh environment. But now what I can do is I can run the generate script, and actually let me show you import CSV. I've actually got the CSV file here. What is it called? It's called, yeah, it would be at the very end, wouldn't it? Spanish Primera Division.csv. So this is all of the data that I need. It has player names, stats, all sorts of other cool stuff, the teams they're on. I'm going to use that to iterate around provisioning this thing. So I'm going to say .generate.ps1, and it's going to cycle through creating the OU, creating the databases, importing the mailboxes, setting the email address policies, all of those things which were in that generate.ps1 file. And it's very simple, right? You know exactly what you'd have to do if you were doing it manually. We just make it easy for you by automating and iterating across data that we've taken from a CSV file. See? Creating the mailboxes now. And if we look inside Active Directory users and computers, hit F5 again, we now have the organizational unit with gradually more and more objects being created into it, 36, 38, 40. See, it's provisioning my environment for me. So from a test environment perspective, at least, this is super useful. And I strongly encourage you to play with that a little bit in your test environments. But for your production environments, it's even more useful, right? Who wants to go in and click 5,000 times to set quotas for people? Iterate it. Who wants to provision a bunch of mailbox settings that are specific to a particular filtered set of users by hand? Iterate it, PowerShell. So let me flip back over again. This takes about 5 minutes to run. There's no sense waiting for it. And we'll close out. So there's a couple of cool other sessions you might want to go to. I haven't really spent much time highlighting the Exchange sessions. I assume if you're here for Exchange, you've probably picked your sessions already. But I do encourage you to take a look at the PowerShell sessions that are out there. If you found the PowerShell stuff we did here interesting and you want to learn more about PowerShell, check them out. Some of them are over, but I think they're doing repeats on some of them. And watch them in replay or whatever if you get your DVD. And finally, some communities that are interesting. I've got a blog. Exchange Team has a blog. Exchange Ninjas is the wiki. Right? I encourage you to have a look at all that. The rest of it's pretty cool too, but I don't really have any connection to any of it. And at the end of all this, my red light isn't flashing yet, and I'm not sure if there's a session after us, but I'm sure we're completely out of time in terms of formal questions, unless they let me keep going. You're welcome to try and ask questions at the microphones. If they shut them off, we can talk here, we can go out in the hall. I'm perfectly happy to talk to everyone. I love to hear what you have to say. So thank you all for coming. Fill out your evaluations. Feel free to try and ask questions at the microphone. If not, we'll talk to you up here. So thank you, everyone.